What if I told you that you could go from building your data pipelines in hours to just minutes? Hi, I'm Ashish. I'm a member of the DLT team, and welcome to our course on building data pipelines with Cursor AI and DLT. So, just before we get started, I just want to point out that this is a beginner-friendly course. So if you only have surface level understanding of DLT, and if you've never used Cursor AI before, not to worry, you'll still be able to follow along with the course. So let's get started by talking about the stars of the show. Well, first we have, of course, the DLT library from DLT Hub, which is going to facilitate a lot of the data extraction, the transformations, and the loading in our data pipeline. If you've ever built a data pipeline from scratch, you can appreciate how deceptively complex the whole operation can be. Something as simple as taking data from one place, transforming it a bit, and then putting it in another place can require a lot of attention to detail. For example, if you're working with an API, you would need to consider authentication, pagination, rate limits, things like retries and graceful error handling. And putting all those things together can make for a very daunting challenge, right? Well, DLT kind of takes off some of that burden. Rather than you having to account for everything from scratch, with DLT, all you have to do is give certain pieces of information in a configuration, and DLT will take up the rest for you. Cursor AI, on the other hand, is an IDE that provides you with a AI agent that can help you with different tasks such as code generation, debugging, and things of that nature. Unlike software powered by LLMs like ChatGPT, your Cursor AI has direct access to your code base, which means it's going to do a better job of getting relevant context, and as a result, it's going to generate better responses. So with the combination of DLT and Cursor AI, you'll now be able to build production level pipelines in much less time. And in this course, I'm going to show you how to do just that. So let's get started. Here's a quick overview of what's going to be covered in this course. Firstly, of course, we're going to be demoing DLT and Cursor AI by solving a real problem. So for this, we'll start by going over the problem statement. Then we'll work on setup, preparing our Cursor AI agent to write code for us. Next will be the actual prompting, in which we work on the actual code generation, the debugging, and those steps. After that, we'll pivot over to talk about the best practices of Cursor AI for those who are still unfamiliar with the IDE and have never used it. And then finally, we'll touch on a very hot topic, Model Context Protocol, or MCP, and we'll be talking about how we can leverage MCP to improve our workflows for building data pipelines. So let's quickly go over the case study for this course. We will be building a very simple data pipeline that extracts data from an API called the Jaffle Shop API and stores it in a DuckDB database after some transformations. This whole process will be facilitated by a DLT script that will be created for us by Cursor AI. So let's touch upon the different components that you see in this workflow. First, of course, is the data source, Jaffle Shop API. You're likely to be unfamiliar with this data source, but this is basically an API that DLT Hub created using the Jaffle Shop data from DBT. So if I switch over, here in the browser, this is essentially the docs page for the Jaffle Shop API. It's using Swagger UI. And if you're unfamiliar with Swagger UI, I can just break it down for you. It's essentially a nifty user interface that lets you interact with the different features of your API. So let's go down here and I'll show you what I mean. So in these headers here, you can see the different endpoints for the API. And if I were to expand on, this endpoint here and scroll down, you can see key pieces of information, including the parameters. Here you can see page and page size. And if I scroll down even more, you can see the responses, right? So here you see the schema of a good response, and you can see here the schema of an erroneous response. And this is all going to be key information that the AI agent is going to need when it's writing our script for us. But more on that later. Let's now talk about our destination, which is going to be DuckDB. And DuckDB is fortunately an in-process database. That means there's no need to set up any service beforehand. It'll be created as we run the script. So basically, our API is already in production, and our DuckDB is going to be created, while our code is running. So the majority of our focus for both the setup and the execution is going to be on Cursor AI and the DLT script. So when we're using anything with DLT, you'll find that we'll be referring to the documentation frequently, because the documentation is already covering a lot of the steps that we'll be taking. So there's no need for guesswork, and all we have to do is follow the instructions that they provide, and it'll be very easy for us to build a pipeline that way. So I'm going to switch over to our browser, open a new tab, and just go to dlthub.com. And under the developers tab, we can see here docs. I'll click on that, and there we go. Here we have access to all the docs, and you'll find that I'll be referring to this page pretty frequently throughout different stages of the case study. Next, of course, we have our Cursor AI. Here I have a new project open in Cursor AI, and it's completely blank, so we'll be starting from scratch. Now that you understand the problem statement, we can get started. And we get started by setting up our Cursor AI so that it's able to properly write our DLT script. Now, guys, if there's one thing you take away from this course, it's that a good setup is critical. Your setup can make or break a project, and that's not really an exaggeration. With a good setup, you can arrive at a production level pipeline with fewer queries, with less debugging, just less time, energy, and cost overall, and it's going to be a pretty pleasant experience for you. On the other hand, with a poor setup, you're going to have to spend more queries to arrive at the same destination, and you'll have to spend more time debugging and troubleshooting, which is going to be a time-consuming and taxing process, and you're going to hate every minute of it. So we want to avoid that, and we can avoid that by following a very simple philosophy, which is that if I only had an hour to chop down a tree, I would spend the first 45 minutes sharpening my axe. Now, in this analogy, our axe is the Cursor AI agent. Before we actually get it to write any code, we want to make sure that it's able to perform at its peak potential. So I'm going to slide over to our Cursor AI. And as you can see, it's completely blank. So if I were to open up a chat, which I can do with Command-Shift-P on a Mac, and click on New Chat, as you can see, I can already, get straight to prompting and asking what I want. But if I were to say something like, build a pipeline, and if I were to submit it, it's going to most likely return a lot of gibberish. And that's simply because it has not been properly set up. It doesn't have the required context to give us exactly what we want and how we want it. So this segment of the course is going to be dedicated to getting it ready to do just that. Our setup comprises 4 simple steps, and I'll be walking you through each one. Our first, of course, is our virtual environment. By the time we have our DLT pipeline written, we want to make sure that it's able to run successfully. And that's what our virtual environment setup is going to be for. Now, the setup can be different for different use cases. So rather than doing any guesswork in terms of what we install, we will be following the DLT documentation closely. So let me slide over. And here's the DLT docs page that I previously opened. And I'm going to go to this installation tab on the left. And here we can see all the clearly written out instructions for our setup. So the first step, of course, is making sure we have pip in Python. I believe I already have that, so I'll be skipping this. And again, one more thing is the instructions varies from different OSs. So I'm on a Mac, so I'm going to be following the instructions for the Mac. Now we'll be creating a virtual environment with UV. So I'm going to slide over and close this chat. We don't need that. And I'll open a terminal. And here I'll write UV, VENV, and I'll just call our virtual environment VENV. And there we go. That was pretty quick. You can already see it here. Now I'm going to activate it with source venv bin activate, and we're in. So that was pretty simple. Let's now focus on the installations. Sliding back to our docs. And now here we get our instructions for installing the DLT library. As you can see, there are different commands for different versions. In our case, our destination in our pipeline is DuckDB. So we want to install DLT with the DuckDB support. So I'll be copying this command, sliding over and pasting. And there we go. Now we could stop here, but there's actually one more library that I want to install, and that is the Streamlit library. So let me do that first, and I will explain why. Okay, there we go. So for those of you who don't know, Streamlit is a Python library that helps you build UIs pretty quickly. In our case, DLT has a Streamlit functionality that lets you visualize your pipeline and different pieces of information like the metadata or the data itself. So of course, when you build your pipeline, you can interact with it however you want. That's up to you. But for the sake of this demo, I like Streamlit. I think it makes things pretty clear. So I'll be using that. So with that out of the way, that concludes the setup of our virtual environment. So our second step is to create a cursor ignore file. If you don't know, or if you've never heard of cursor ignore, it's basically a file that tells your AI agent which documents or which directories should be omitted. It's very similar to a git ignore file, which tells Git which files or which directories shouldn't be tracked. This can be very useful because when, for example, code bases are really large, there can be a lot of content, a lot of which isn't helpful for the task that your AI agent needs to do. For such cases, you can explicitly tell your AI agent through your cursor ignore which files, which directories should be omitted from consideration. So adding a cursor ignore file is going to be really easy. I'll switch over. And here to our left, I'm going to go to new file, and I'm simply going to type dot cursor ignore, right? And that's it. So now we can include all the files and all the directories we wanted to omit. And I'll start by including the venv directory that we created. So in our case, we want to build a data pipeline, and that requires information on mostly DLT and the data source. But the actual dependencies, the libraries that are in venv, don't really contribute to that. So we can safely tell our AI agent to ignore this folder. Now let's talk about cursor rules. Cursor rules is arguably the most important part of the setup, so let's take our time with this. Rules in Cursor are essentially persistent pieces of instructions that you provide to your AI agent. They're essentially prompts, but they're reusable and they get added behind the curtain. Let's say that you wanted your AI agent to respond in 100 words or less every single time. You could, of course, include that information in your prompt, but that would be pretty repetitive. You would have to mention it every single time. Rather than that, you can create it as a rule once and then feed it to your agent, and it's going to consistently follow that rule going forward. In our case, we want to add rules to our AI agent to make sure that it follows the best coding practices and the best DLT practices. So right now, as I already mentioned, our AI agent is very limited and it's very lacking. I'm going to slide over. Like I said, if we were to ask it right now to build a data pipeline, it's going to do a pretty poor job because one, it does not have the sufficient context. It doesn't know how to write a data pipeline. And two, it's going to very likely hallucinate. Hallucinate basically means that if it doesn't know a certain piece of information, it's going to fill in that gap by itself by making something up. And we want to avoid both of those things, or we want to address both of those things rather. So if you were to, let's say, if you were to go to the cursor documentation, they would tell you that, you can add your own rules. And that would be done by going to settings, firstly, which is, you do that by Command Shift P and going to settings. And I believe it's in general. Yes. So you can go to the general settings and, you can add a new rule. And I'll just add something just for the sake of it. I'll just call it demo rule. And I'll just say, I'll make up something. Here you can see that the rules can be written down here. It's in markdown format, but it's not necessary. I could just say, for example, write good code. And then if I were to plug this in as a rule, our AI agent, whenever we give it a prompt, is always going to refer to this instruction, right? And that makes things easy for us because it eliminates our redundancy of giving it the same information in the prompt over and over again. However, there are good rules and there are bad rules, right? Even if you have a certain intent in mind through your rules, it doesn't mean that your agent will understand it as you should, which is why, crafting rules can be pretty time consuming if you want to do it right. Thankfully, when you're building data pipelines, you don't have to worry about this at all. For DLT, you have the option of loading rules that have already been crafted for you, that have already been tried and trusted, and that have already shown to generate good results. So I'm going to close this demo that I created. It's not important. And rather than, us building our own rules, I'm going to delete this. Rather than us building our own rules, we will simply load the ones that DLT have provided for us. To do that, of course, we simply need to go to the documentation. And on the top right, we can see a search bar. So I'm just going to type in cursor rules, and we'll see a section dedicated to just adding rules to cursor. So I'll click on that, and it directs us to exactly where we want to be. And as you can see here, there are essentially two commands that we need to run in order to get our rules. So first is DLT init REST API DuckDB. So I'll copy this and I'll explain what this does. So when we run this, it's going to create a DLT project. So let's give this a minute. Yes. And there we go. If you look on the left, you'll notice that a number of files have been added. First, of course, you see the DLT folder, and it's got these config and secret TOML files. So for example, if your API has, let's say, an API key, then this would be the place you would store that information. We have a getignore file, we have a requirements, which we don't really need on our case. And then we have our REST API pipeline. Now, this REST API pipeline is basically an already functioning DLT pipeline. And I'll just let you look at, how it looks. It's very akin to, what you see in the documentation. And the role of this file is to basically just serve as a reference, right? So now with this file, when we ask our agent to build a DLT pipeline, it knows exactly what to do because it can use this file as a reference. So that's our first command. We can now move on to our second command. And now this command is actually what's going to set up the rules. So I'll copy this and paste. And there we go. Now, if you look to the left, under cursor/rules, you'll see these different files that have been added. And you can see how thorough and meticulously written they are and how they account for different scenarios and factors. I won't be going through everything line by line because we would be here all day, but I will, touch upon the main rules, the main roles of these rules. And firstly, of course, it's to provide context because right now the AI agent in Cursor does not know what it means to build a DLT pipeline. So we can tell it that through all these pieces of information. We can, for example, talk about the parameter configuration, which we do here. And we can, explain every single parameter in detail. I'll move on to a different file. We can talk about a different factor, variable like pagination. As you know, some APIs, including the one we're using, has pagination. In other words, it doesn't, rather than giving us all data in one batch, it gives it to us in multiple batches. And this means that you need to know how to navigate paginators. The second thing that the rules have to do is to mitigate hallucination, as I said. We want to avoid any guesswork on behalf of the AI agent. So, which means that if the agent doesn't know anything, rather than making something up on its own, it should simply tell us. It should say, hey, I can't build the data pipeline because I don't have, ABC. And I think this line in Rule 11 is a good example of this. I'll read this part in blue out loud. Do not guess, do not invent code. You should have documentation for everything you need. If not, ask user. This is an excellent example of an anti-hallucination measure. We're making sure that, once again, that our Cursor AI agent is only going to properly write our pipelines when it has all the information it needs. And if it doesn't, it'll focus on first getting that information. So that concludes this segment of the setup. The final step of our setup is to create our external docs. Now, to explain the importance of this step, let's go back to our cursor. We have so far our virtual environment set up, we have our cursor ignore file, and we have our rules loaded from DLT. If we were to ask our agent now to write a DLT pipeline that collects data from Jaffle Shop and stores it in DuckDB, it's still most likely going to fail. And that's because it knows nothing about Jaffle Shop. It doesn't know things like the URLs, endpoints, and other important parameters. We still need to provide that information. And in Cursor, you can provide information like documentation through external docs. And I'll show you how to do that. So first, I'm going to go to Settings in Command-Shift-P and Settings. And I'll switch to the Features tab. And I'll scroll down until I find Docs. There we go. And in the Docs section, I'll just click on Add New Doc. And here we will be prompted to paste the URL for our docs. So I'll be fetching that right now. I'll switch over to a browser. Here's our docs, and I'll simply copy this URL and paste it here and enter. And yep, I'll just call this doc Jaffle Shop and I'll confirm. And just like that, our external doc has been created. How easy was that? So with that out of the way, that concludes our setup portion of this course. Let's do a quick recap on what we've done during our setup. We created our virtual environment, as you can see here, that has all of our dependencies. We created a cursor ignore file, which will tell you what files and directories to omit for the AI agent. We have loaded our rules using the DLT commands, as you can see here. And we've also included our sample REST API pipeline, which will show our AI agent how to write a DLT pipeline. And we also previously added an external doc with the Jaffle Shop documentations. This was a pretty time-consuming process, and I did explain a lot of novel concepts to you, but I really wanted to take my time to make sure you understood every step of the setup and its purpose, because like I said, setups do make or break your project, and it's really important to be thorough with this step of the project, the workflow. But we've gotten that out of the way, so we can actually move on to the fun stuff, which is writing code. So let's get started with that. I'm gonna create a new chat, Command-Shift-P, go to new chat, and as you can see here, I'll close our terminal. As you can see here, we have our prompt. Before adding anything, I'm going to first provide the relevant context. So the first thing I want to add are the rules. So as you can see, if I just type rules in the search bar, I can see the 4 files that were provided by the DLT command. So I'll add all those 4. And the next thing I want to include is the external docs that I had previously created with the Jaffle Shop documentation. So for that, I will say at, and I will scroll down to docs. I'll click on Jaffle Shop, which I created. Now I have everything added. I'm going to tell our Cursor AI agent what I want. I'll simply say the following: create a DLT pipeline that extracts data from Jaffle Shop API and stores it in a DuckDB database. I want to keep the scope of this project a bit smaller, so I'll just focus on 2 endpoints: collect from customers and orders endpoints. Now, this is a pretty short query, but remember, we've already added a lot of context through our rules and our external docs. I'm not sure what's going to happen when we submit this, but I'm expecting it to come close to what we want. So let's submit. Okay, so that was a pretty big response. So let's break everything down simply. First, it's saying that the documentation that we provided is pretty limited, so they still need more information from us. So we can make sure to actually provide this information by ourselves. Now, remember, this is exactly what we wanted to do. If it doesn't know something, it's going to tell us that it doesn't know something rather than doing any guesswork. Let's look at what it needs. First, the base URL, then it needs the authentication, it needs the exact endpoints, and it needs the pagination. Oh, and rate limits. Sure. So I'm going to basically provide that information. So I took a few minutes to see what the AI agent needed, and I made sure to find those details in our documentation. Just as a reminder, our documentation is this page here. It's a Swagger UI, which gives us all the information that we need, including our endpoints, our schemas of responses, and so on and so forth. So I'll go back. So the first thing it wanted was the base URL, which I provided. It asks about authentication, and I say there's none. There's no API key or anything like that. Confirmation of endpaths, which I provide here. And finally, example responses from both endpoints. And to get this, I simply copied the schema of the responses for each endpoint. Let me scroll back to the docs. So for example, to get a sample schema for the customer's endpoint, I expanded this, and I'll scroll down, and I would simply copy this and give it to the AI agent. If you're working with an API that doesn't provide this, then you probably have to run an API command with something like curl, and then just paste that response to your prompt for your AI agent. Let's go back. So I believe I've given it everything it wants. So if I submit this, it should be able to generate a functioning pipeline. Let's see what it does. Okay, let's break down this response very quickly. I'll start from the beginning, which is here. So there we go. It's finally created a DLT pipeline. I'm going to click on apply, which just creates the file with the code. And before I accept it, let's go down a bit more. So it gives us the key points for what it has done, including plugging in all the values. And finally, if you go down, it just gives us instructions for how to run the thing, which is nice to have. So, oh, sorry, let me just shrink this. Now, if you were to look at this file and compare it to the sample pipeline that was given, you'll notice a lot of similarities in terms of the configuration. And just based on that, I believe that this is something that we can work with. So going back to our file here, I'm going to accept it. And now just because I accepted it doesn't mean that it's going to work. That's still something we have to test. But at the very least, it's a very good start. And I'm going to actually run this thing. So here I'm in my virtual environment. I'm simply going to run Python, Jaffle Shop, pipeline, and let's see what it does. Okay, we immediately get an error, not a problem. So it looks like our pipeline has a resource extraction error, which we need to resolve. Now, when we're vibe coding or using, cursor AI in general, there are two ways we can, debug. The first is, of course, we can manually inspect the code, and if we find the fix, we can manually make the fix. The other thing we can do is we can actually, give this error to our agent and have it propose a solution. Both solutions have their own pros and cons, but I think it's advisable for you to be familiar with both. Let's start by letting our AI agent take a crack at this. So I'm going to copy this whole thing. I'll copy it and I will paste it here. And as you can see, it's included as our context in this terminal section that you see here. And I'll just say fix the error. Simple as that. Let's press enter and see what happens. Okay, now let's break down what it's saying. So basically, in short, it's saying that there's an issue with one of the parameters that is in this configuration. Let me scroll down. And I believe it mentions that, yep, the key change is in the data selector configuration, right? So again, this is just a detail, but essentially what I want to highlight is this method of debugging. Instead of us manually tracing our mistakes, we can simply hand it over to our bot and let it propose a solution for us. Of course, that's one way to do it. It's not necessarily foolproof because even during debugging, our AI agent can make mistakes. But for now, let's apply this change and let's see what happens. So as you can see, the assigned value to data selector is now different, as shown in the comments. So let's see what happens if we run the code once again. Oops. Let's try that again. Oh, and there we go. It looks like our pipeline is running properly. Let's break this down though. So if I show you the configuration for our pipeline, you will see that for the progress parameter, we've assigned log, which means that the whole thing is being logged. And If you look at the terminal, you'll see that, the logs for, the data extraction. Next, you can see the two endpoints being shown here, and next to each endpoint is a number. And this number represents the number of data items that are being collected. So you will notice, let me zoom in a bit so you can see clearly. You'll notice that the number next to customers is 935, and the number next to orders is, 12,000, and it continues to rise. So customers has stopped, which implies that there are only 935 data items, i.e. customers, in this data source, while the orders endpoint still has data that needs to be collected. So overall, I think that, it's yet to see if the data has been properly transformed and loaded, which is something we'll check out in the data validation. But for now, it seems like at the very least, we have our functioning pipeline. So I'm going to wait for this to finish running. And once it does finish running, I'm going to switch over to data validation. Okay, so I fast forwarded to the point where the entire pipeline is done running, and it ran without any errors, which is great, but the job's not done. We still have to perform data validation. After all, we asked our pipeline to do a relatively complex operation, from taking data from a semi-structured format, transforming it, and putting it in a structured database. We want to make sure that everything has been taken and everything has been processed and stored properly. So this is what we're going to be finding out through our data validation. Now, you can interact with your data and perform your checks however you like. If you want to directly interact with your DuckDB database with SQL queries, go right ahead. You can even ask for help from your AI agent to draft your queries for you. In our case, I will be using, as I mentioned earlier, DLT's Streamlit functionality. I think its UI gives you a pretty good illustration of the pipeline and the data itself. So that's what we'll be going with. Now, in order to run our Streamlit app, I'll just be referring to our DLT docs for instructions. So I'll slide over there. And on the top right, you'll have the search bar. And I'm just going to type in Streamlit, and I'll look for the specific section that I'm looking for. And here we are, view data with Streamlit. I'll just click here, and here are all the instructions that I need. If I scroll down, we have the prerequisites, which I've already taken care of in the beginning as a part of the setup, so I can skip this part. And now I'm going to launch the Streamlit app. And this can be done with this command here, DLT pipeline show. And as you can see here, the pipeline name here is a placeholder. We'll have to replace it with the actual name of our pipeline. So let's copy this, and I'll slide over and paste. Right? Now, if you want to know the name of your pipeline, there are many ways to do it, but in our case, we can just look at the value assigned to the pipeline name parameter, which here is Jaffle Shop. So I can just replace pipeline name with Jaffle Shop. Okay, and I'll press enter, and this should work without a problem. And there we go. It launched our web app in our local host. So if you're new to the Streamlit functionality, this is all going to look very new to you, but I'll just break it down very quickly. On our left, we have info on our pipeline, including its name, the location of our DuckDB database, which is our destination, and so on and so forth. In the middle, we have our tables, which includes their respective schemas, what fields they have, what data types they have. And here we can see we have our customers table, we have our orders table, and okay. And when we scroll down, we see another table called orders_items, which is interesting because we had 2 endpoints, and now somehow we've ended up with 3 tables. So we'll have to figure out what's going on there. And if we scroll down, you also have the option of running the SQL queries if you want to interact with the database that way. So First, let's decide on our data validation checks. If we go back to our Jaffle Shop API docs, and I'll go all the way to the top, let's get a good understanding of the things that we need to look out for. Firstly, if you recall, our API source uses pagination, meaning rather than giving us everything in one sitting, it actually gives our data in batches or pages. We want to make sure that our pipeline didn't just take one page's worth of data, but instead it actually iterated through every single page and collected the respective data in each page. Let's scroll down. If we look at our responses, we see what fields there are. In this case, it's ID and name, and what the data types are. Later on, we want to make sure that the data types and the fields are matching what is shown in this schema. Let's go down to the orders endpoint and see what we should be expecting here. Similarly, this also has pagination, so we want to make sure that we're collecting all of the data and not just the 100 data items that are being showed here. Let's move on to the actual responses. Okay, so this is interesting because similar to the customer's response, we see that this response has a semi-structured data, but it also has a nested format. So as you can see here, there are a lot of key value pairs in the beginning, but in the items field, there are actually a nested JSON, meaning for this key, we have a corresponding set of key value pairs as a value, which means that if we want to convert this, if you want to store this data in a relational database, we need to properly unpack this stuff right here and put it in a structured format. So luckily for us, this is one of the things that DLT is going to do for you. It's going to look at a given API response, and it's going to decide the best way to flatten everything out and store it in a table. All we need to do is make sure that DLT actually did its job. Overall, just to sum it up, we want to make sure that one, everything has been collected because this API has pagination. Two, that it's collecting all the fields and is using the right data types as shown in the schema. And three, that it's actually flattening everything out when applicable. Let's go back to the dashboard and actually begin our data validation. So first, of course, we have to make sure all the fields are there. In the case of customers, yes, we see the ID and we see the name and we see the data types are right, they're text. Of course, there are additional fields that have been added by DLT called DLT load ID and DLT ID. Of course, this is not within the scope of our course, so I won't be really discussing them. But if you're interested in what they are and what roles they serve, feel free to check out the docs. In Streamlit, you have the option of showing the data. And in this case, it's showing us all 935 rows. So this is already telling us a few things. Firstly, we're able to see that everything has been properly stored in structured format. And second, we're seeing that this table has 935 rows. Now, since the DBT data is available to all of us, I already know that this is exactly how many rows are in the source and that everything has been collected, which is great. So now I'm going to move on to orders. And this was, I believe, the more tricky table. But if you compare the fields and the data types to what was shown in the documentation for the API, which I'll go to, you can see that for the most part, everything is looking good in terms of the fields and the data types. But you'll notice that there's one field missing, and that was the more problematic field, which is items, because this was actually in a nested JSON format. So we need to see how DLT handled this and that it handled it properly. If we scroll down, we'll see actually that there is a third table rather, called orders underscore items, and that it has a child-parent relationship with the orders table. And in this table, we have the information in the items field, such as ID, order ID, and SKU. Just as a quick reminder, I'll go back to the docs. These are the exact fields that are in the items field. So basically, just to sum it up simply, rather than storing the items, having items as a column, DLT basically took out that nested format, the nested data from which was in the items field, and it flattened it out and it created a brand new table for it. And it connected it to the original table from the orders endpoint, which means basically that out of two endpoints, we have three tables. So we have our customers table, we have our orders table, and we have our orders items table. And you'll notice that all the fields for every endpoint is there with the correct data type. And if you were to, let's say, show our data, you'll see that everything is structured properly. Of course, with the Streamlit functionality in DLT, you can scroll all the way down and you can actually run queries to interact with your database. So just as a quick example, I could just say, if I wanted to see how many rows were in a table, I could just say select count from orders, and then I could just run it and see what it says. In our case, it's 61,948, which I already know is the right value, which means that everything has been collected. So that's going to be it for the data validation for this particular project. It was pretty short and brief, and I only checked for the major requirements, including the fact that everything has been collected. We have all the fields. All the fields have the correct data type, and that nested data was handled properly. With this quick data validation, we made sure that all of those things were done and done properly. So we can stop here. But in your use case, if you're building a DLT pipeline, then you can, of course, add more validation steps as required. And using Streamlit is optional. If you have a preferred way of doing it, then feel free to use that way. You can write your own. You can write your own queries. You can use your Cursor AI agent to help you out with data validation by writing queries for more complex logic, and figuring out that and making sure that all of your checks have been made. So that's going to be it for this section of the segment of the course. With the data validation completed, we have finally finished our case study. As a quick recap, I first set up our Cursor AI agent to make sure it could perform at the level that we needed and that it could build our pipeline the way we wanted. Then we actually began to interact with the agent to get it to run the pipeline. We gave it information that it asked for when it requested it, and then we used our agent to debug issues in the pipeline. Next, we ran the pipeline, and then we just now finished performing our validation checks to make sure everything was there. Throughout this whole process, I'm sure you will agree when I say that this was a pretty low level of effort. There wasn't really much cognitive load that came with this task. I didn't have to write a lot of code, and most of the work on my end was basically just copying and pasting commands from the DLT documentation. That being said, I myself already have some background with both the DLT and Cursor AI, but that might not be the case for you. You might be familiar or comfortable with a different IDE, or you might be familiar with using different Python packages or libraries for your data pipelines. So inevitably, for those cases, there's going to be a bit of a learning curve in DLT. So for this segment of the course, I want to explore the answer to the question, is it worth it? So by it meaning, is it worth taking the time to learn DLT and Cursor, and incorporating these tools to build data pipelines from here on out. And I think our current case study, the one with Jaffle Shop API, can serve as a good reference. Let's think about how we would have built this pipeline without the use of DLT and Cursor. Well, firstly, regardless of what package you'd use, it would require maybe 2 hours of data engineering. You would have to consider all the different factors in the Jaffle Shop API, including its parameters, its pagination logic, its JSON and nested JSON format, which you would have to manually transform, and also other logic like retries and graceful error handling. All those things put together would take up, let's say, about 2 hours. The second thing is it's going to require high cognitive load. In other words, it's going to require a lot of mental effort to basically put all those pieces together and create a functioning pipeline. You could either create those, assemble those pieces manually, or you could interact with an external LLM application, such as the ones from OpenAI or Claude. And even with those cases, since those applications don't have direct access to your code base like Cursor AI, you'll inevitably have to do a bit of debugging. Now, let's look at our results or our workflow when we used DLT and Cursor. First, there was an estimated 15 minutes of data engineering. Of course, I'm omitting the time I spent explaining certain things and just focus on the time I actually got to building things, including the setup, the prompting, the debugging. So I spent about 5 minutes on the setup. This is everything from creating the virtual environment to setting up the Cursor rules. If you recall, a lot of those steps were just required 2 to 3 commands, and they were pretty easy to carry out. Next was prompting. If you recall, there were about 3 prompts that I needed to type and then to read the responses for. And then later, there was about 5 minutes for debugging. If you recall, there was one issue with the code, and I basically used the help Cursor AI agent to address it. So yeah, this is more of a guesstimation of 15 minutes of data engineering. The cost, on the other hand, since we're using Cursor AI, there is a cost. And we'll discuss the pricing model for Cursor a bit later on. But just for now, just know that I am currently using the Pro license, which charges about 40 cents per prompt. And since we used 3 prompts, just as a recap, our first prompt was to actually instruct it to build the data pipeline. The second prompt was to give it the additional information that it requested for, including the base URL and the endpoints. And then the third prompt was when we gave it the error message and asked it to debug. So that's 3 prompts. And put together, that amounts to less than $2. And finally, with our workflow, there was low cognitive load, right? Because I ended up writing 0 lines of code. So I pretty much did not write any Python code. All I did was, copy and paste some terminal commands from the DLT docs. And when I did run into errors, I basically just let the AI agent handle it on my behalf. The one thing that I did do that was more manual was the data validation, but even that was pretty straightforward thanks to this Streamlit implementation. So with the breakdown out of the way, let's revisit that question that I had previously asked. Was it actually worth incorporating both DLT and Cursor AI to build our pipeline for our case study? And the answer is yes, absolutely. With this solution, we saved a lot of time. We spent a lot less effort. Again, I didn't write a single line of code, and I did all of this at a very, very, very low cost. Now, the caveat is that I had to follow a lot of the best practices for both DLT and Cursor AI. Now, for DLT, I've explained a lot of the features in DLT that you can leverage to make your pipeline building experience pretty easy, a lot of which I got help from the documentation. But I have yet to cover the best practices for Cursor AI. So for those of you who are interested in building something of your own with Cursor, but are still new to Cursor, the next segment of this course is going to be dedicated to explaining some of those best practices that you should follow. This segment of the course is going to be dedicated to discussing some of the best practices for using Cursor AI. It's more geared towards people who are still new to Cursor or haven't even set it up in their system, but it can apply to everyone. Now, this is important to cover because unlike other IDEs, Cursor AI does come with costs and or limitations. Before we go on, let me explain what I mean. So I'll switch over to Cursor AI's pricing model. And here you can see the different pricing plans that are provided to all of us. So if you are, completely new to Cursor, you haven't set it up and you haven't installed it, then, thankfully you do have a free tier option. You can, play around with the IDE. You can test its different features and you can get a good feel for it before it expires. And then when it expires, you'll have a good idea of whether or not you want to pursue the Pro plan. The thing about the free tier is though, and let me zoom in here. The important thing about the free tier is that you have limited number of requests, right? So here it says 50 slow requests. Now, in Cursor AI, a request is essentially any interaction you have with your AI agent. So when you ask your AI agent to generate code, when you ask it to debug, when you ask it some, some related questions like how to improve your code or any form of interaction, that is a request. And in the free tier model, you have 50 of those requests. And when you exhaust those 50 requests, then your free tier is done, and you will have to, upgrade to a pro or a business if you want to continue using Cursor and its features. Now, if you don't follow the Cursor's best practices, then you'll find yourself quickly using up those 50 requests, which you want to avoid because you want to get the most value out of those limited number of requests. On the other hand, if you are already on a paid model like the Pro model, then obviously you have unlimited requests as shown here, but you will now be charged for those requests, of course. So if you don't follow the best practices, then well, you can still have as many requests as you want, but the cost for those corresponding requests will quickly add up, and you want to avoid that, of course. So with that in mind, let's start discussing the best practices. Firstly, of course, is in Cursor, you want to provide sufficient context. So as I emphasized during the setup, context is everything. You need your AI agent to have all the information it needs before you actually ask it to perform certain operations. So that means that you need to explain what to do, how to do it, give it any relevant content. In our case, it could be about the data source, about the destination, about the transformations. And all this information can be given in the form of a prompt, in the form of cursor rules, in the form of external docs, and so on and so forth. You might also need to share, relevant snippets. So if you saw our example when we were doing our case study, our agent asked us for certain pieces of information, including, a sample JSON response for our endpoints, which I provided. So those are the types of things you should be ready and able to provide your Cursor AI agent in order for it to perform well. Next is, of course, to craft rules with intent. To begin with, if you use the DLT AI command, you should be able to load the already well-crafted rules from DLT, and those are specifically designed for DLT pipelines. So that'll do a lot of the heavy lifting for you. But there might be cases where for your specific use case, you might need to add additional rules. And for those cases, be sure to be very unambiguous with what you expect. Make sure your expectations are precise. Make sure that everything that you include in your rules encourage the best practices so that the resulting code from your agent is readable and efficient and high performant. Next is, of course, to validate your code output. When you are running a DLT pipeline, or when you're creating a DLT pipeline, just because it is, it runs properly doesn't mean that it's done its job successfully. You have to make sure that the data in the destination is, as it should be in terms of the structure, in terms of the number of records, and so on and so forth. You want to make sure that the logic that you had written down in your prompt has been correctly translated in your code. And one last thing is you also want to make sure you check for hidden assumptions, edge cases, anomalies, and so on and so forth, depending on your use case. And next is to, of course, use cursor requests intelligently. Now, this especially applies to people who are in the free tier that have only 50 requests at the very beginning. You don't want to use your agent to do every single thing, right? Because that would be a waste of your requests. Rather, it's best to focus on the more high-value tasks, such as the complex business logic. A good example of this is, of course, building the data pipeline with the DLT, which includes, defining all the parameters and the configurations, because that would take a long time to do by yourself manually. On the other hand, simpler things like creating virtual environments, installing dependencies, or creating cursor ignore files, those are things that you can do within a minute on your own, and it's not really optimal to use up a request for such low effort tasks, at least if you're in a free tier. The next thing is, of course, to batch your questions. When you're using your AI agent, you can basically ask multiple questions in one prompt. So rather than, like, if you have 5 questions, for example, rather than asking one question per prompt, you can just put them all together, and that will be sufficient. It will answer all of your questions within that one prompt. So that's just a way to be efficient with your requests usage. Let's now talk about Model Context Protocol, or MCP for short. This is a very, very hot topic at the moment, and it's being heavily discussed. And if you've already heard of it, or if you've already done your own research on it, I wouldn't be surprised. Since there's already so much material on MCP at the moment, this course is going to be more focused on talking about MCP with the use case of building better data pipelines. But before we get into that, let's take a step back and talk about LLMs. LLMs are very sophisticated architectures that can do amazing things. But at the end of the day, they're text in, text out models, right? They input text and they output text, which on its own makes it very, very impressive, capable of doing great things. We already saw how it's able to generate code once we give it, just a couple of instructions. We see how it's able to, read a script in Python and then suggest improvements. Those are some of the things you can do just with an LLM alone. However, LLMs on their own are also limited. There are things that they can't do. A good example of this is in something we could see in our data validation. When we ran our data pipeline, all our data was in a DuckDB database. But when we wanted to validate the data, we had to manually open up a Streamlit dashboard. We had to, maybe run some SQL queries. We had to manually inspect the schema and to make sure that everything was done properly. The reason we had to do that was because our LLMs cannot directly query our DuckDB database. Remember, they're text in, text out. So this connection from LLM to DuckDB is not there on its own. And that's where MCP comes in. MCP is essentially a protocol that lets our LLMs extend their capabilities to external tools or other context. The way you implement MCP is by creating MCP servers, which are lightweight programs that follow the Model Context Protocol. And they serve as an intermediary between your LLM and, in this case, our DLT project. Now, each MCP server is going to be dedicated to enabling your LLM to connect to a specific tool or resource. So for our example, or for our use case where we built a pipeline where we took data from Jaffle Shop and stored it in DuckDB, let's think of how we could incorporate MCP to improve that whole process. Here's one potential idea, right? So we could create 2 MCP servers. The first MCP server would extend the LLM's capabilities to the DLT Hub documentation that's on the web. And the second would extend its capabilities to the DuckDB database. Now, with access to the DLT Hub documentation, the LLM can do a much better job at debugging or troubleshooting or suggesting improvements to DLT pipelines. And secondly, with access to DuckDB database, the LLMs can directly query off of them, and that helps it do things like data validation, things that we had to do manually without MCP. Overall, having these two MCP servers that would give us the LLM access to the DLT docs in the web and the DuckDB database would make the whole process even more streamlined. So, of course, this is just a brief overview of MCP and how you can potentially use them to improve your DLT pipelines. We're not going to get into any of the technical stuff that's outside the course, that's outside the scope of this course. But I just wanted to introduce to you the idea and how you could potentially improve your vibe coding experience even more with DLT and Cursor AI. If you are interested in MCP for the sake of building better pipelines, of course, DLT is currently working on building MCP servers that are dedicated solely for DLT pipelines. So if you're interested, then feel free to check out the documentation. So if you made it this far, congratulations. This concludes our course on building data pipelines with the DLT and Cursor AI. Just as a quick recap, we built a real data pipeline that takes data from an in-production API, does some transformations, and stores it in a relational database. And we were able to do this by leveraging the best of DLT and Cursor AI. We were able to do everything from the setup to the actual execution in maybe 15 minutes, omitting the explanations. And we spent about $2 or maybe even less on the whole pipeline, and we did not write a single line of code because we had Cursor do the initial write-up, and we also had to do the debugging. So I hope you learned a lot from following along me with this course. I hope you enjoyed yourself, and more than anything, I hope you're inspired. I hope you watch this course and feel inspired to build something of your own. If that's the case, great. Feel free to install Cursor on your machine and build something. And when you build something, feel free to share your experiences or share your projects on social media or GitHub or wherever. And more than anything, just keep on learning.